We're going to wrap up our study of organic chemistry by looking at oxygen-containing organic compounds. And there's a summary of this stuff on page 666. These are the ones that you will be responsible for in this class. They are alcohols. Alcohols have a general formula of ROH. ROH. We'll talk about what these stand for in just a bit. Aldehydes have a general formula of R, then a C double bond O, H. Then we have ketones. Ketones have a general formula of R, C double bond O, R. Then we have carboxylic acids. And a carboxylic acid has a general formula of R, C double bond O, OH. Then we have ethers, not ethers, but ethers. And I didn't come up with these pronunciations, so don't get after me. I'm not responsible for what they did long before I was on this earth. Ethers. And then the last category of compounds we'll look at is esters. And esters have a general formula of R, and then it's going to be C double bond O, O-R. Now, part of the reason why I color-coded these is because the portion that is red in each one of these molecules acts as what we call a functional group. And a functional group is a portion of a molecule that makes substances that share this portion of a molecule function similarly as a whole. So in other words, if they have one of these red portions that I've shown, any molecule that has one of these red portions allows them to function similarly as a group or as a whole. The letter R stands for an alkyl group. Now remember that an alkyl group would be like a methyl group or an ethyl group or a butyl group or an octyl group. It's basically just a whole bunch of carbons and hydrogens. So this would be like an alkyl group right here. Remember, an alkyl group is basically an alkane minus a hydrogen. So again, an alkyl group is represented by an R. And it could have any number of carbons, anywhere from 1 up to hundreds of carbon atoms. Then we have these portions of the molecule. Ones that we've shown in red. We see an OH. And I'm showing a line in there because that line represents a covalent bond. That's not supposed to represent a charge. That represents a covalent bond. And this is referred to as a hydroxyl group, called the hydroxyl group. It's not a hydroxide ion. If it was a hydroxide ion, we would have write OH with negative charge out on the side. So this here is a hydroxyl group. It's where it makes a covalent bond to some other groups of atoms. Then we have this type of arrangement. We have a carbon double bonded to an oxygen. Of course, because carbon can make 4 bonds, it has to make 2 more bonds to something else. This here is called a carbonyl group. Now, I didn't come up with these pronunciations. Don't ask me why. The first one sounds like this, hydroxyl group, kind of with a short sound, and this one says carbonyl with a long E sound. So hydroxyl group and carbonyl. If you want to be consistent in pronunciation, I would think it'd be hydroxyl and carbonyl, but it's not. It's hydroxyl and carbonyl group for the pronunciations. And then if we combine together a carbonyl group and a hydroxyl group, so in other words, here's the carbonyl group, and we put an OH on there. Again, this is a carbonyl group and a hydroxyl group together. We basically combine the 2 names and we refer to it as a carboxyl group. And so these here, what I've shown in red, represent different types of functional groups. And then also any of these here that I've represented in red up here as well. So in the color coding scheme, these here represent different functional groups. And again, molecules that have these particular functional groups in there, for example, if we see this functional group right here, the carbon double bond is an oxygen and an OH. This is called a carboxyl group. And anything that's like that is classified as a carboxylic acid. So when we talked about the success in organic chemistry, the first piece of success we mentioned the other day, which was our ability to count carbon atoms. Your second piece of success in organic chemistry, especially at this level, is your ability to identify functional groups. Those are your two main things. Your priority is to count carbons. Your second priority is to count or to look at functional groups. And if you can't identify functional groups, then you're never going to have success with organic chemistry. And this is a series, I believe, of about 7 or 8 questions I have up here on the Socrative app. And so we're going to look at some models. And so you're going to see a picture of the model, and I'm also going to show you the 3-dimensional structure of the model up here. We're going to go through these because, again, in order to achieve success with these, you have to be able to identify them by group. So, and you talk with your neighbors if you need to on these. On this first one, we want to tell, is this an alcohol, aldehyde, ketone, carboxylic acid, ether, or ester? 5, 4, 3, 2, 1. This one here is a carboxylic acid. Carboxylic acid because we have the C double bond O, OH here on the end. Next up, so very good, 95% of us on that one. Next up, we have this molecule. 5, 4, 3, 2, 1. All right, perfect, way to go, an alcohol. We don't need to explain it, so then we should be able to get this one. 5, 4, 3, 2, 1. This one here is an alcohol. So here's an alcohol. It's an alcohol because we have an alkyl group. Remember, an alkyl group is a bunch of carbons and hydrogens attached to an OH. So here's the hydroxyl group. The hydroxyl group is attached to a bunch of carbons and hydrogens. This is an alkyl group. It's a hydrocarbon that's missing one hydrogen. There's the OH. This here is an alcohol. Let's do the next one. Talk them over with a neighbor if you need to. Next we have this molecule. 5, 4, 3, 2, 1. So here's a ketone. That's correct. Ketone. Now it's not an aldehyde. It turns out that aldehydes and ketones are very often confused with each other. But why is it not an aldehyde? If it's an aldehyde, what should be next to that carbonyl group?
Hydrogen.
Should be a hydrogen, exactly. It should be an H. So if we look at it, there should be an H adjacent to that carbon. There's not a hydrogen adjacent to that carbon. There's another alkyl group over here, so that makes this a ketone. But as far as ones getting confused with each other, aldehydes and ketones are very often confused with each other. Ethers, this one here would definitely not be right because in an ether, the carbon or the oxygen that's in the center must have single bonds. There's no double bonds in an ether from the oxygen. Okay, we'll look at number 6. Number 6. As we've seen already, answers can be repeated. And we'll count down. 5, 4, 3, 2, 1. So here's an aldehyde. Why is it not a carboxylic acid? What else would a carboxylic acid have?
Oxygen.
There should be another oxygen. That other oxygen would be stuck in
Ca.
right here. So this one here is an aldehyde. Next up, we have this molecule right here. 5, 4, 3, 2, 1. This one here is an ether. It's an ether because we have an alkyl group surrounding this oxygen. We have an alkyl group over here. We have an alkyl group over here. So it's ROR as the general formula. ROR. Next up, we have this molecule. Is this an alcohol, aldehyde, ketone, carboxylic acid, ether, or ester? 5, 4, 3, 2, 1. This one here is an ester. Not a carboxylic acid. If it was a carboxylic acid, what should we have here at the very end? Just a single hydrogen, exactly. It would be C double bond O, OH. If it was a carboxylic acid, but what we have here is an alkyl group on this end, alkyl group on this end. That's making this one here an ester. So with that in mind, any questions on the classifications on each of those?